Okay, this lesson is the introduction to our unit comparing linear equations to exponential equations. So in this first lesson, we're going to look at key features or critical parts of graphs. What are the highlighting elements that we can compare between them? So before we compare them, we first have to identify some critical information or key features of any graph. And again, we're going to look at both linear and exponential. So obviously the first thing we got to always look at is, the difference between a linear and an exponential. Again, a linear, always we're looking for a straight line, whereas exponential we have some sort of curve, either a decay or a growth. Okay. Now we spent a lot of time in the last unit talking about intercepts. So again, intercepts is where it crosses the y-axis. So here, where it crosses here, and as an ordered pair, we have an input of 0 and then some sort of number that goes there. For an x-intercept, it's the exact opposite. You have your xy axis, and we're looking for where it crosses the x-axis. And again, we're solving for x when the output is 0. Okay, so we did a lot of that with intercept form in our last unit. Now, increasing and decreasing, the key is whenever we talk about anything on the graph, we always do it in terms of how the domain is changing, how the x value is changing. So in this case, we're always looking at as the x value increases. What that means is going from left to right. Okay, so as you move across the graph, going from left to right, what is happening to the outputs, the y values? Okay, so if it's going from left to right and it's going up, that is an increasing function. Okay, and if you're going from left to right and the function's going down, we would have that as a decreasing function. Okay, now the next thing we have to look at is not so much how it's changing, but where in the graph it is. So we're looking for positive and negative. Okay, so if you look at a XY graph, anywhere above the x-axis, anywhere up here, we're going to have positive, whereas anywhere down here is going to have negative values. Okay, so let's go back to our pen here. So again, positive up here, negative down here. So some examples you could have is you could have a decreasing value, but it's positive, and you could also have a increasing function, but has negative. So the positive and negative has to do with the outputs. Okay, but again, we are always doing it in terms of expressing it in terms of where does it happen in the graph, and it has to do with the inputs, the x's. Okay, and we'll show examples of this. Okay, another thing is relative minimum maximum. Okay, so a lot of times we have a graph, but if you have, for instance, a graph and a line starts and stops, you may say, okay, in this graph, this may be the lowest, this may be the highest when it goes a min-max. But you might also say, well, what if, the graph gets stopped short or we're only looking at a part of it? Well, this becomes the relative max, okay? And we'll see better examples of this. So I think a key feature that we'll come back to is the key word relative. But we're basically looking for the lowest output and the highest output. And again, this has to do with outputs, where um, what is that value. But again, we're saying when it happens with the domain. Asymptotes, this is for exponential functions only. So this is what happens as the line approaches something. Okay, so notice as the x's get bigger, the line, or the curve I should say, flattens out. Now it never touches it. It never touches, but it gets near value. So if this value is somewhere around, 3, we would say, well, it approaches the line y equals 3, and that would be an asymptote. So it's a line that you approach. And I think that's the key word, is approach. Okay, and domain we talked about again is we always show it as, either a list of numbers or an inequality, and it has to do with where on the graph what x values are important. So we're going to quickly look at two examples here. Now the first one as a linear example, okay? It's a taxi cab company that's charging, so much for a ride and another $1.50 for every mile. So this graph represents the cost for one ride. So when you first get in the cab, you have an initial fee of $2.75, and as you drive down the road, miles, your price goes up. So let's identify some key elements. What's very important about this graph? Well, the first thing we got to recognize is where do you start? So we'd say that this has a y-intercept of 0, 275. That is critical, always where you start. So that's a key element. Okay. We could also say the outputs, the money, is all positive. You are paying a positive amount to the cab company. Okay, notice we have no negative values here. So we would say that this graph is positive. Also, as we're moving from left to right, notice what happens to the value. It increases. Okay, so the fact that it's an upward slope, it means that it increases. Okay. Um, we have a minimum value. What's the lowest the cab will pay? Well, $2.75. Where does it happen? At 0 miles. Okay, so notice I'm kind of phrasing my language. Okay, is there a maximum value? Well, technically no. I mean, you could really drive forever, and so it would go to infinity. So you'd say it has no maximum. You would not say infinity is a maximum. You just say, well, it goes to infinity, therefore it has no maximum. Okay. Is there an asymptote? Not in this case because it's not exponential. It's not approaching any number. It's honestly just going to infinity. So notice when we look at a linear model here, we can identify some very key elements. It's positive, it's increasing, it has a minimum value and a starting point um, when the input is 0 and the output is $2.75. Now let's go ahead and look at the next example. Here we have an exponential function. It's a pendulum, and we measured the number of swings that you can see right here, and we measured how tall it is off the ground. And as the pendulum swings, it doesn't go as high, just like if you're on a swing in the backyard. The first couple swings are high, and then it just kind of slowly peter down until you stop. Okay. So what I did here was I took this data, and it's a bunch of discrete points because if every swing is its own point, and I plotted them on Desmos. So let's take a look in Desmos and see what it looks like. Okay. Now we can see the dots here. Okay, and it is a discrete function, and there would be some dots in between. There really should be a dot for everything. So I'm going to go ahead and change this so we can see it a little bit better. And I'm going to make it, I'm going to connect the dots just so we can see those values. Now let's just talk about this graph. Okay, I'm not going to write too much about it. Let's just talk about it, and I'll point to it. One, the entire graph is positive. Notice the outputs are all positive. Okay, they're all right here. We have nothing down in the negative portion. We have nothing over here. So the outputs are all positive. Now, as we're moving from left to right, as we're moving across the x-axis, what happens to the outputs? They are declining, so they are decreasing. So here's an example where we have decreasing outputs, but yet they're still all positive. Okay, so that's two different elements, but a good example showing the difference between them. Okay, do we have a maximum value anywhere in the graph? We sure do. We can see it in the list right here at 80. We can see it on the graph right here at 80 as well. Okay. Do we have a minimum value? Well, not really. We can notice it comes down and it approaches the x-axis. That's the definition of an asymptote. So we would say it approaches the line y equals 0. Does it ever actually touch 0? No. So it never has a minimum. It has an asymptote, and you'd say it approaches the line y equals 0. Okay. So notice we have a linear example and an exponential example. They both share key elements. Maximum, a minimum. Is it positive? Is it negative? Is it increasing? Is it decreasing? So we can kind of use these key features to compare the graphs. But inherently, the graphs are different. One is linear, one is exponential. So as we take a look at this first lesson, we're going to kind of use these key features to identify comparisons and be able to contrast different functions in this unit.